Ladies and gentlemen, now let's welcome Dr. Ing Christian Hanser, the CEO of RIB SAA. Mr. Christian Hanser has been working on automation topics related to the precast concrete industry. He founded SAA Engineering in 1997 for production automation solutions in the prefab construction industry. He is a passionate promoter of the digitalization of the construction industry. Hence, SAA supplied more than 200 precast plants around the globe. In October 2015, SAA merged with RIB Software AG to mutually develop our vision of industrialization of construction engineering. Now, Mr. Christian Hanser.
Now it's working. Very welcome from my side. Good afternoon or good morning. As André said before, running together is our slogan, and running together with you is my task for now, to speed up and to stay on schedule for the panel discussion afterwards. Many thanks to my pre-speakers, to Mr. Van and Mr. Dienst, because they helped me to shorten my lecture a little bit, but they said so many very, very important things. And what I want to show you now is how we can support that process, the precast process, from the software side. As a few figures about our company, which belongs to the group since 3 years. And I really like the comparison of Mr. Van about the 3 stages of BIM. BIM in information modeling, that's a design task, an architectural task. BIM information management, that's the old task or the long-lasting task of RIB Group, yeah, to optimize the management, the project management of construction. And the missing link, that are we, building information manufacturing. We are the experts or the excellence center for smart production in the group, and we are at home in Vienna with about 55 employees. And some other figures you see here. That are some of our top clients, and I want to point out the two in the first line here in China. That's the Baoye Group, where we realized 2 plants together during the past 3 years, and that's for sure my home, where we are supposed to realize 40 plants together, and the first one is nearly ready from our side. We will start installation in a few days or a few weeks. And I want to point out the technology partner, especially Precom Pro, Mr. Dienst, who will be our partner at my home to realize the installation of the control systems. And at that point, I want also to say that we have Precom Pro on site for the installation, for supporting our task, and that's also a very, very good opportunity for my home itself to contribute also in his management capabilities. He just lined out before in his last speech. That's about our solutions, our capabilities for the precast industry. You see, PPS, production planning and scheduling, that's the anchor in the I2 4.0 world. That's where we start implementing the precast planning task, the project management for prefabrication in general. Then it goes to the production, and the MES, the manufacturing execution system, is more or less the brain of the production. There is all the planning done for the shop floor. ICS stands for intelligent machine control. That's the robot systems, that's the transportation system, that's the stockyard systems. SCE is a smaller part, that's automated stockyard management, which we will also apply for my home, for example. Yeah, and the lower level, you see all these control tasks, the control machines, the different robots for different tasks. What I want to say in this speech is, first, I go back to the modular construction because that was the topic for today. first I want to summarize the building systems. Mr. Jösch has done a lot of that, so I can really speed up that part. Then I want to show you some details about plants we already realized together with partners in Germany, in Singapore, and all over the world. And then I want to line out the end-to-end process we can manage by using I2. What can we provide on tools to make the job on the shop floor easier for the people, to bring the work the work to the people and not the people to the work, as André lined it out in the last speech. Yeah, modular building systems, there are typical methods. If we talk about concrete, then we can cast it in module molds, either with a movable kernel or with a kind of upgrade technology. That means you pump the concrete from underneath into the mold and get it casted in as a complete mold, or to cast it in a so-called C mold and turn it by 90 degrees sidewards. The second system is to do wall panels, slab panels, to mount them together as a module and then put it on the finishing line. And that you can do either on a standard carousel line, as we use it for element prefabrication, or you can do it in a battery mold, where you can achieve smooth sides on both sides. And then you can do it on a butterfly mold. I will explain that later, how that works, that combines both technologies. And the third way to produce modular building systems is by timber construction, by steel construction, covered with panels of PVC, of concrete, as Ms. Ann outlined it, and also Mr. Jösch before. Once the module is ready, you need a lot of tasks to finish it, to make a complete installation in the production facility before you deliver on site. You see on the right side some pictures of such a finishing line. MEP is a big issue. Then bathroom installation is a big issue. Flooring, roofing. All these things have to be done on a kind of continuous work on the module to get it done and to get it to the stockyard. And to support that process, we had to develop a lot of new functions in our MES system to support that by means of material lists, by means of instructions, so that the operator knows exactly what to do, that he can see the drawings on his workplace. Yeah. And we also want to get a feedback about how long he has to use for this task, and to get a feedback about a bottleneck analysis of the process. And last but not least, quality control is very important. Otherwise, you plan with repair from the beginning, which is definitely the wrong way to do it. One of our recent projects, we are nearly finished, is at Maxperg. Maxperg is the biggest precast company in Germany, and they have set up a completely new factory for producing a module system for modular housing. They have investigated a lot of time and a lot of effort to find out what's the best building system for it. And they outlined also the big advantages they get from that. It's like defining a house or a building from a catalog. You see here the variations, but they are aware that these, let's say, 20 types will not be that what they need. That will be much more, and they will get a much bigger variety of their modules. And that's why they need to apply BIM for production manufacturing. That's the pilot project they already realized in Germany, and you see that there's no difference from a standard, let's say, prefabrication building. Very nice views of the floors, of the rooms, and of the house itself. If we look at the production line, you see at the upper left corner that there is enormous stress on the logistics. You have to prepare all the material on time to have it ready for all the work steps on the finishing line. The element production, that's well known, more or less. Yeah, we produce the wall panels, we produce slab panels, and we put them together in a module. But to have all the parts for MEP, for painting, for tiling, right on time, right on the spot where it's used, that's a huge logistic task to do. And at the end, yeah, we have to ship it in a more or less container size, as Chris said in the beginning, and then mount it to the building itself. What's now a battery, a butterfly mold? You see it here in a sketch. That's more or less, there are two molds which are combine the advantage of horizontal preparation with reinforcement, with mount parts, and then clap it, hang it on the crane, put it in a battery mold, and cast it there to have two smooth sides after casting. And that works like this. This crane is fully automatic. The MES knows where to put it, how to put the two sides together, and then an automatic concrete spreader does the rest and fills it up with concrete. The production line for the finishing task looks like this, and it starts, and that's also a very important thing to point out, it starts with, let's say, cosmetics on the concrete and milling of the connection plates. The type of connections Bögel figured out was to cast connection plates with the modules, and then put the whole module in a big mill and mill it on all sides to have really accurate edges to put the modules together at the construction site. That's different from many other systems. I just had a discussion in KSA in the United Kingdom. In Saudi Arabia. They say we don't have an earthquake issue at all. We simply put them together. We don't need any connection at all. That's completely different, and in China it would be much more difficult you have to spend much more brain and much more ideas on the connections to come up with the earthquake issues you have here. A few photos in the finishing line. You see the modules move through the finishing line, and every work step is designed so that it can be done within 1 hour. So every hour, one module comes out of the production hall and can be either stacked in the stockyard or directly transported to the construction site. A second system I want to line out shortly, that's a tilting mold, where it's a really big machine where you produce the whole module with a movable kernel and then tilt it by 90 degrees, so upside down, more or less. Yeah? And that's used for garages, for example, but even also for room cells like this. Yeah? We have 2 clients in Germany which are using that kind of system for doing their modules. A finishing line for garages, which we are just busy installing. is a line like this. It's very similar to that we have seen on the photos from Maxperg. We have, for garages, we have the task of the roofing. We have to take care of that. We have the coating inside, coating outside, sometimes tiling the ground and the inside. Then we have a curing area in between. And last but not least, bring in the door, the garage door and the windows. We support the whole process, the whole end-to-end process for all kind of prefab constructions, especially for the module construction. We have extended our offers. This process you know well, or we have seen several times in the I2 charts. So that's the digital twin, which we start first. We do the virtual modeling, and then we compare it. We are able to compare it with the physical process. And in every stage, we can see what's the difference in budget, what's the difference in time. And if we add the precast process, then we have that already included in the PPS modules directly in I2 4.0. And it looks like this. That are the modules we supply in I2 4.0. And I want to point out in the process the prefab engineering, which is a very, very important step in between, because there you take the design drawings and you add all the details for production. Otherwise, you won't be able to do any automation in the production if you don't add all the details, all the geometric details of the mounting parts, all the details of the reinforcement. That's really compulsory to get any level of automation in your plant. Yeah, and then you have to do your capacity planning for sure to know when do you have to produce the parts and when do you have to deliver it. And once you can release production, then it's handed over, all the data is handed over to the MES in the production facility, and there the whole production management is done by the MES. And at the MES level, we start with the so-called BIM qualifier. We qualify the data, we check the data if it's sufficient for production according to the applied automatic stage. Then we have to do the production planning, put panels, slabs on the molds, or prepare it for full molding. And during the production, the MES distributes the data to the different machines and gets back the feedback from the control system. And in that stage, you only have to monitor if there is any error in the system or any failure. And at the end, you do your reports, you do your bottleneck analysis, and you see what you could afford during the supposed production time. That are a summary of the tasks of the MES. But what I want to point out is how can we support that, and we have a short video.
One part of the Smart Factory concept is to support employees with new hardware, such as large touchscreens or iPads to digitalize production. RIB SAA has turned this into reality by offering I2 Smart Production Solution, an intelligent software solution that digitalizes the entire concrete prefabrication automation management process. The system contains multiple options for extracting production information, allowing for necessary information to be directly available on the working station devices. With an intuitive user interface, the system empowers smooth workflow management.
To explain it a little bit more for the modular construction. We call that smart stations. We bring the smart information to the work steps on the shop floor. For example, to avoid paper at all, because then you are fully flexible with your planning. You see here a drawing of the pallet which shall be produced. You see also a material list which is needed for the worker on that stations. If you look now on the next station, for example, you see the drawing for the MEP. He can zoom in, he can directly access the drawing for module construction. We can also apply quality cameras to take a photo from the module, from the pallet, wherever in the plant, put it into the database and make it accessible if you get a reclamation from the construction site later on, for example. And we have apps for smartphones, for tablets, to manage all this, to take photos on the stockyard, take photos on the construction site, and store that with your model and with your production data. You can also add quality reports by clicking a set of malfunctions or failures on the product, for example. We have a smart station for demolding. The colors show you exactly where to put the panels. If you mix up different stacks for transportation, you can easily find the way how to move them to the next to the stack where to transport it to the stockyard and later on to the construction site. And we support the workers on the control level with the visualization screen. And with the online statistics, we can show on a big screen in the production how far it is, what's the trend, are you on schedule, or do you have to speed up? Last but not least, we can go back in the history. We can move the operation of the plant to any specific time and analyze what has happened then, why did we produce more or less than expected, and give that in graphical reports. So that's how we can support a production facility, how we can support even the module construction, which has more needs than a standard panel production, and that's how our clients like to work and they are equipped with. Thank you very much. I close at that point to save the time for the panel discussion.
Yes, perfect.